Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, we discuss about Pearson coefficient of skewness. So previously in this chapter, you already know a bit about skewness, such as using stem and leaf and box and whisker in order to roughly estimate the skewness. But to accurately estimate the skewness in the distribution, we will use the Pearson coefficient for this purpose. Okay, so this is actually the last learning outcome in the subtopic 6.3, which is measures of dispersion. Right, as you can see here, there are three types of skewness. The first one is almost symmetrical. Okay, almost symmetrical means the position of the mean, median, and mode almost in the same position. So in these cases, we will choose mean as a best measurement, right? Because it is almost symmetrical. In other hand, if our distribution is skewed, whether it is positive skewed or negative skewed, the skewed here means if the values of the skewness is more than 0.3 or less than negative 0.3. So in these cases, we consider it is a skewed, and in these both cases, whether it is skewed to the left or to the right, we will choose median as a best measurement. And as you can see here, if the positive skewed, or in other words, we can use skewed to the right. So the mode is located on the left and mean on the right. Mode and median on the left, mean on the right. In other hand, if the negative skewed or skewed to the left, so the mean and mode on the right of the mean. Okay, so look at the position of the mean on the left or on the right. So this is a situation if we have skewness in the distribution. Right, to find the coefficient of skewness, that is Pearson's coefficient, we will use either the formula using median or the formula that using mode. If you're using a formula regarding median, after you subtract between the mean and median, you have to multiply the difference by 3. On the other hand, if you use the formula that using mode, you don't need to subtract by 3. Just subtract between mean and mode. And in both cases, after we subtract, we will divide with the standard deviation. Okay. And notice the notation below here. If the distribution is negative value, so that is less than 0, we mention it is about negatively skewed. Okay, or skewed to the left. If the distribution is positively skewed, the value will be positive. We can mention about positive skew or skewed to the right. Okay. In ideal cases, almost impossible to find out solidly 0. But if we have 0.0, then we can consider it is almost symmetrical. Okay. Okay, later on, in the end of this video, we will discuss about how to use the coefficient of variation. So these cases, we will divide the standard deviation with mean, and this we have to multiply by the percent. Okay, 100%. So compared to the Pearson skewness, we don't have percentage, only 0 point something. But here for CV, that is coefficient of variation, we have to multiply by 100 because the answer is in percentage. Okay. Right. So this is about the degree of the skewness. remember that I already mentioned about it is almost impossible to have a solid symmetry, but if you have a plus minus 0.1, we can consider it is as a almost symmetrical, whether negative 0.04 or positive 0.03. So this is what we consider as a almost symmetrical. If the value of skewness is plus minus 0.1, then we cannot use the notation almost symmetrical anymore. But if it is still greater than 0.1 but less than 0.5, okay, in both cases positive negative, so we consider as a slightly skewed, right? And if the value of the skewness is greater than 0.1 but less than 1, so same situation for the negative value, so we consider as a moderately skewed. So a positive value moderately skewed to the right, if negative value moderately skewed to the left. Or you can use negative value negatively skewed lah. But if you have a degree of skewness here, moderately skewed, I think not very convenient to use the word negative anymore. So we use moderately skewed to the left, okay, better than the negative. Right, and then lastly, if the value of the skewness is more than 1, okay, same case if the less than negative 1, so the value of skewness we consider already high, so we use the notation highly skewed, okay, highly skewed to the left if the negative value, okay, and positive of course lah to the right. Okay, so remember about this, so later on if you confuse how to put the conclusion whether it's slightly moderate, so make sure to refer to this chart. Right, so next we go to the example 21. So find the mean, median, mode, variance, standard deviation, and then F Pearson coefficient, and then lastly state the reason whether mean and median is better. Remember, for question G, we refer to the notes earlier. There is a note on the right. It mentions whether it's median or mean is better. Okay. Right. So we go to the solution. Always remember, if we have a class interval like this, so you have to add another columns to make it easier for us to calculate the parameters related. So such as if you want to find the mean, you have to find the midpoint x, okay, and then the fx. But here we also find x squared and fx squared because we also need to find out the standard deviation. So standard deviation, before that you have to find out the variance. So that's why we have to add another two columns for x squared and later on fx squared. And then also we also add the cumulative frequency here because we also need to find out the median. So remember what's your purpose, what the question asks, so you know what another column that you have to add up. Okay, right. And also, since we find the mean and the median and the mode, so in both cases you have to use the lower boundary. So make sure you check out the lower boundary. So since there is a difference between the last value on the previous class interval and the starting value in the next interval, so you have to put a 0.5 before that, okay, as our lower boundary. Right, so now we move to the find the mean. So we know formula for the mean, sum of fx over sum of f. So we already sum below here 852.5, so we just divide by the total frequency, which is 25. Then we get the value of mean, which is 34.1. And then, right, the S here refers that we have to find out the median. So we want to locate where's the median located. So 12.5, which is already greater than 12. So the median will be in the intervals between 30 and 39. So the lower boundary will be 29.5. So we use the lower boundary 29.5, and then the S value already calculated, actually n over 2 minus cumulative before that, which is 12, and then divide by 4 the frequency on the class interval, and then the size is 10. So remember, to find the size, we cannot subtract 39 minus 30, 29 minus 20. You have to use the lower boundary. So 39.5 minus 19.5. So that's why you got 10. So press your calculator, and then you find out the value of the median is 30.75. And then next, we want to find the mode. So you have to find out the difference between the frequency on the model class and the frequency on the class before and after. So this is the model class 7, which is have a highest frequency. So 7 minus the class before that, 41. 7 minus 5 is 2. And then 7 minus 4 is 3 for the class after that. Okay. Then we can find out the mode. So remember, the formula of mode notation is X cap. So it is located here, the interval class 20 and 29. So the lower boundary would be 19.5. So 19.5 plus D1, so 2 over D1 plus D2, so 2 plus 3, 5. And then the size of the class interval is same, okay, which is 10. Then we got the value of mode is 23.5. Right. So after we find out the mode, before we can proceed to find the skewness, remember you have to find out the standard deviation. So I already write down the sum of here for our purpose in formula of variance. So sum of f is 25, sum of fx is 852, and sum of fx squared is 35,000. So we put in the formula of variance, so 1 over n minus 1. So n is actually sum of f, which is 25. So 25 minus 1. And then inside here is sum of fx squared, which is 35,000, minus the square of sum of f, which is 152, divided by 25, which is n. That is sum of f. So check your calculator. So the value of the variance is 254, which is luckily we don't have any decimal after that. Okay. So we find out the square root of that, which is our standard deviation, because remember in our formula of skewness we use the standard deviation. So the value of standard deviation is 15.94. Then after we find out the standard deviation, we can proceed to find the skewness. So remember the skewness, if you use the mode formula, so mean minus mode over standard deviation. So substitute the value of the mean and the mode that we find out in the previous slide. So we got the value of the mode, the value of the skewness is 0.665. So 0.6, remember it is already greater than 0.5 but less than 1. So the conclusion would be moderately skewed. So since the positive value, moderately skewed to the right. Okay. Right. So this is formula using mode. If you want to use median, so remember you have to put 3 outside after you subtract mean and median. So substitute the formula. So this is the value of median. Then you find out the value is 0.6305. Notice that the value of the skewness is not same, right? 0.63 here and 0.66 over here. But don't worry about that. Both values are correct, okay? And it's not very far. And if you want to put the conclusion, since it is already also greater than 0.5 but less than 1, also the conclusion would be the same, right? Which is moderately skewed to the right. So no problem. Either you want to use a median or you want to use mode formula. Okay, don't worry about that. Now, lastly, for the last question, the question asks about which one is better for measurement? Is it mean or median? What's the answer? Since we have moderately skewed here. Yeah, of course, median is better, okay, because since we have a skewness already greater than 0.5, so we can conclude that it should be median, okay, because data is already more dispersed, okay. So this is the conclusion, okay, median is better. Okay, so now we move to the example 22. So notice here, the interval that given here is less than. Remember in the tutorial, I already discussed about the more than and how we find out the frequency from the cumulative. So we have to subtract. So same cases here, but it is in opposite. So remember, less than 0.5 is 0, means that 2.5 would be our lowest value. So the first interval will be 2.5 until 5.5, and the frequency for that is 5, because 5 minus 0 is 5. So with that, I will show later how we find out the class interval. But before that, we go to the question first. So the question first, A, find out mean, median, and standard deviation. And then B, find out the Pearson skewness and interpret the answer. Interpret answer means slightly, moderately skewed. And then lastly, state mean and median, okay? So the same situation, B and C with the previous question. Right. Before we find out, calculate the values, remember I mentioned earlier about the intervals. So 2.5 will be the starting value, and the until 5.5 will be our first class interval. So for that, the frequency is 5. I already mentioned about that. Okay. So you just follow after the next class interval, and you just follow the subtraction from the cumulative to find the frequency for each class interval. And then until you get the last class interval, that is 40.5 until 17.5. So the frequency, lastly you subtract, you got 10. So to make sure the frequency is correct, so you can total out, find the cumulative, that is sum of f. So we got the total is 50, which is correct. Okay. Then after these two already done, the interval and the frequency, then we can proceed to add more columns. So remember, since we want to find out mean, you have to add x and some fx, and then don't forget to find the sum of fx below here. And also, since we want to find out the variance and latest standard deviation, you have to add x squared and also fx squared, because we want to find the sum of fx squared below here. And then lastly, also we want to find out the median, so don't forget to put another column for the cumulative frequency, that is capital F here. Okay. Right. So remember, you want to use median. So median, half of the total frequency is 25, right? So our median should be located in this class interval. So I already write down the lower boundary for this class intervals that we use in our calculation. Okay. Right. So first find out the mean. So already have a total here. So just put in the formula 536 over 50. Then we got 10.72. And then, as I said earlier, we already determined the S, that is n over 2, which is 25. So I already mentioned it is located here in this class interval. So this is our lower boundary. So put it into our formula, 8.5 is our lower boundary. Then the S here, that is n over 2, 25 minus 15, the cumulative before that, divide by 13, that is the frequency in this class interval. And then the size is 3. So since the difference is same, so we just we can subtract directly. So 11.5 minus 8.5, which is 3. Okay. Then we got the value of the median is 10.81. Next, we want to find the variance. So we already have a total sum of fx squared. So put it here. Sum of fx squared minus sum of fs 500, and we have to square here over n, which is sum of f 50. And then below here, don't forget n minus 1, which is 50 minus 1. Okay, and then we got 14.53. Then later, don't forget to square root to find the standard deviation. So square root of 15 is 3.812. Right. So since we already find out the mean, median, and standard deviation, we can proceed to find the skewness, which is the formula that using the median. So since you are using the formula having median, don't forget we have to put 3 outside here. Okay. So calculate, then we got negative 0.07. Notice that it is less than between negative 0.1 and positive 0.1. Okay. So it is very small. So very small, almost 0. Then we consider the conclusion from the skewness here is almost symmetry. So since it is almost symmetry, then of course we will choose mean. Okay, it's better for describe distribution because it is almost symmetry. So remember, if 0.0, whether it's positive or negative, the conclusion will be almost symmetry. Right, so now we move to the example 23. So this will be the last example in this video. So in this video, apart from Pearson skewness, we will also later on use the coefficient of variation, okay, to answer the second part of the question, which is the comparison between the maths and the physics. Right. So first we answer the first question. Compute the Pearson skewness. Hence, state the shape of the distribution. Okay. So as usual, from the class interval, so we rearrange. Right. So now look at our table. So the question just asked to find the skewness, right? And remember, we have two types of formula to find skewness. The first one is using median and second one is using mode. So from these two formula, I choose mode. You know why? Because for the median, you have to put another column for cumulative frequency. So for mode, you don't need, because you can determine easily the model class and then just subtract the frequency before and after the model class. So it is much easier if you want to use, if you use the mode. Okay, so in this case I will use mode. So since this is model class, so this is the lower boundary for the model class. So because it is 65 and 66, so it should be minus 0.5, so 65.5, okay, for the lower boundary. Right, before we proceed to find the value of mode, so first we find the mean. So we know the mean, we use sum of fx, so already find out below here, 6,700. So we substitute and divide by the total frequency, 100. So we got 67.45. And then now we find the mode. So as I said earlier, to find mode, we have to subtract the model class and the frequency before and after that. So before that, D1, so we got 24. And after subtract with the after that interval, so D2, which is 15. So we can proceed to the formula of mode. So the low boundary 65.5, D1 24, D1 plus D2 So 24 plus 50, and then the size is 3. So since it is changes 0.5, we cannot 68 minus 66. That one will got 2, which is wrong. So you have to use the lower boundary and upper boundary. So 68.5 minus 65.5. So we got the size of our class interval is 3, not 2. Then we calculate, use the calculator, and you got 67.35, okay, for our value of the mode. Then remember, we still have to find out the standard deviation. So first we find out the variance. So this is the formula of the variance. So 1 over n, which is sum of f, so 100 minus 1, and then sum of fx squared here for 455,000 here, and then minus sum of fx, which is 6,700. So here we have to square the sum of fx over n 100. Then we got 3.6, okay, which is already low, the variance, because this is the variance. So and when we find the standard deviation, we got 1.9, which is in my opinion is already very small. So we can predict when we find the Pearson skewness. So Pearson skewness already also we already find out if we subtract between mean and mode, both of them are 67, right? So 0.45 and 0.35, so we got 0.1, right? So which is already very small. And of course I can predict that we have another cases of almost symmetry here. Yeah, correct, 0.05, which is less than 0.1. So of course the conclusion would be almost symmetry. So since the conclusion will be almost symmetry, I think the better measurement also we will choose mean, right? Okay, since it is almost symmetry. Okay, so this conversion of variation, I think that one we just go to the next slide for conversion of variation. So conversion of variation, so this is what already shown in the previous slide. So I put it again here because we want to compare, okay, from coefficient of variation between maths and physics. So the formula of coefficient of variation here, actually the above here is the standard deviation divided by the mean. Okay, remember 67.45 is the mean. So standard deviation over mean times percentage. So we got 2.82%, which is, I think, very small. Okay. So if you read the question, the question also give the value of standard deviation and the mean for the physics. So substitute that value to find the CV for the physics. So 9.8 is standard deviation divided by 69, their mean. So I think it should be larger than maths, right? Yeah, correct. 14.15, which is larger than maths. So which one is better, the larger one or the smallest one? So the answer would be yes, the smaller one, because the lower CV value means math score is more stable, and because it is less dispersed, okay, compared to physics. Right. So that will be the conclusion for the question, and it will be the end of the example, and also it will be the end of our chapter 6. So in the next video, we discuss the new chapter, which is the permutation and combination. So I just like to remind the students, since our syllabus already at the end of the chapter 6, so make sure you answer all the tutorial question regarding chapter 6, because later on we already move to the chapter 7. So do not wait anymore. Finish up quickly your tutorial question. Okay. So until then, thank you very much. Bye bye.